So this is a 2014 sample paper, question 5. Okay, so both sample papers is the same. Diagram below shows a shape with two straight edges and one rectangular edge, or irregular edge. Irregular means this side here, two straight edges is this one here and this one here. By dividing the edge AB into 5 equal marks, 5 equal intervals, use the trapezoidal rule to estimate the area of the shape. Record your constructions and measurements on the diagram, give your answers correct to the nearest centimetre squared. So we can measure A all the way to B, we get 15 centimetres. 15 centimetres divided by 5 gives us 3 centimetres. Okay, so it's going to be, that's the first one there, first mark, 6. Let's make sure just mark it accurately. 6. Then we have 9, and then we have 12 and 15. Okay, so we just might just rub out this one a little bit, get it more accurate. There we go. Now our job is to draw up the line and measure it upwards. Okay, so what we're going to do is we're going to rotate this around, so it's like this, and we're going to start drawing up our lines. Okay, start off with the first one. We're going to get this here should be about 5.5. Okay, so we're talking about 5.5 there, maybe around 5.7 maybe. 5.7. Okay, the next one, measure straight over then, or the first one. That there will be 4.5. 4.5. And the next, measure over the next one. Measure upwards. What we get there is about 4.9. Okay, so 4.9. Next one after that. 4.9. Okay, so one after this. Level it up. And we're looking at around 3.4 for that one, because 3.5 is here, so about 3.4. Okay. Now what we do with the one after this, move over. And we get about 3.8. Okay, so 3.8. And finally after that, we're just going to shift this one slightly to the, just get rid of the top part here. Okay, and then finally the last one, it has no height at all because it's going up, and it's basically 0 because it doesn't go vertically upwards. Okay, so that's 0, and the one before we thought was 3.8. We'll just measure it again. Yeah, about 3.8. Now that's done, we're going to use our trapezoidal rule formula. Trapezoidal rule is the area is approximately equal to h over 2 times okay, so the trapezoidal rule is the rule you find in your notes, and this is it here. Now what this means is, this is the first line, this is the last, and what all this means here is 2 times the remaining. Okay, and this is where h is the gap in between each one. So remember, h is 3 because it's 15 divided by 3. Okay, so it's going to be first plus last plus 2 times remaining. Okay, and the remaining added together. Close bracket and close. So when we go through this, okay, what we're going to be doing is we're going to be putting h equals 3 over 2 The first is 4.5, the last is 0, and then 2 times the remaining is going to be 2 times 5.7 plus 4.9 plus 3.4 plus 3.8. Now, what we got to do next is we got to use the calculator to figure this out. So we're going to do first and foremost is just do what's in the brackets, okay? Starting off, so we'll do thing in this part here, okay? And then we'll multiply the answer by 3 over 2. So we're going to be getting 4.5 plus 2 bracket 5.7 plus 4.9 plus 3.4 plus 3.8 close bracket. We're going to get there is 40.1. Now 40.1 multiplied by 3 divided by 2 is going to be 60.05. Okay, so it's going to be 3 over 2 multiplied by 40.1, and what that will get us here is 60.15 centimeters squared. Okay, so explain what is meant by the converse of a theorem. So the converse of a theorem is a theorem formed by interchanging the hypothesis and conclusion of a given theorem. Okay, so there are some geometric statements that are true, but they have converses that are false. Give one's geometric statement and state also the false converse. Okay, so an answer to this one would be congruent triangles have equal areas, and that the converse is triangles with equal areas are congruent. The converse is false. Okay, now to show you what this means is imagine we had a triangle. Okay, the triangle has the same base ABC. Okay, so we could have a triangle like this. Okay, where the base is going to be 10 and the height is we'll call the height I don't know, 8. Okay, so the area of this triangle is 40. Now remember, area is a half base by height. Now imagine that I then did a red triangle, which is located over here, and it still has the same base. So what happens is in the red triangle, okay, it's still a half base by height, but look at this, it goes up here, down here, and back again. Now these two triangles actually have the same area as each other. The reason being they have the same area is that their perpendicular height is still 8 and the base is still 10. So this one's going to be a half base by height, which is a half 8 by 10, which gives us 40. Okay, so basically congruent triangles are triangles that have the same lengths and the same angles, but we can clearly see that the red triangle and the black triangle aren't congruent. So triangles with equal areas are congruent is a false theorem. Okay, now next one. The King of a Hill triathlon race in Kinsale consists of a 750 metre swim followed by a 20 km cycle followed by a 5 km run. The questions below are based from 224 athletes who completed this triathlon in 2010. Moira is analysing data from the race using statistical software. She has a data file which compares time for each part of the race, along with various other details of the competitor. Moira produces histograms of the times for the 3 events. Here are the 3 histograms. Okay, use the histograms to complete the following sentences. Okay, the event that takes longest on average to complete is now on average would be sort of in the middle. Well, swimming takes about 18 minutes in the middle, cycling takes 42, while running takes about 24 to 26. So we're going to talk the cycle is the longest longest event that takes to complete. Okay, in all 3 histograms the times are grouped in intervals of. So interval is what is the size of the bars basically. Okay, so look, you can see that it goes from 18 to 22 with 2 bars, so 20 in the middle. Okay, same thing here, 46 to 50 with 48 in the middle, and then 28 to 32 with 30 in the middle. So each bar length would be like 28 to 30, which is intervals of 2 minutes. Okay. The time of the fastest person in the swim was between, so the fastest person in the swim is in between 10 to 12. We don't know if it's like 10 minutes on the dot or 11 minutes 59 seconds, we don't know. But basically it's in between 10 to 12 minutes. The median time for the run is approximately, right, so you're talking about the run. So the median is usually dead center, so we're talking about somewhere in here. So it'll be somewhere between 24 to 26 minutes, or you can say approximately 25 minutes if you want. Okay, so which event is the most spread out? Okay, the event in which most times are spread out is so you can see that the lowest time for the swim is 10 to 30. So 10 going up to 30 is the fastest to the slowest. The cycle is 30 to 60. And finally the run is 16 to 38. So you can see that 30 to 60 is the biggest spread. So the time which the event in which the time is most spread out is the cycle. Okay. Moving on to the next one. Meyer is interested between the relationship between athletes' performance in the run and the cycle. She produces the following scatter diagram. Okay. Now, the correlation coefficient between the time for these two events is one of the following below. Write down the letter corresponding to any correct answer in the box. Okay. Well, correlation coefficient measures how much spread there is in results. So if you have a perfect correlation of 1, okay, your results are very close to the line. In some cases, very much on it. If it was a correlation of -1, it'd be going in the opposite direction with the lines scattered on it, like this. That's a negative correlation, so that'd be pretty much very close to -1. Now, difference between plus 0.7 and minus 0.7 would be this. 0.7 would have more scatter on it, as would minus 0.77 would have a bit more scatter on it, like this. And finally, 0.13 would basically have no trend whatsoever. You see that it's very hard for any correlation to happen, as same thing with minus 0.3. So I'd say 0.77 is the correct answer here, because it's a positive correlation and the spread of results is away from the middle line. Okay, Frank was the slowest person in the run. How many people took longer to complete the cycle than Frank did? So what we got to do now is we got to look for Frank, who was the slowest person in the run. Okay, so we go up to run and we go up to the very top, and here we can see Frank is located here. Okay, and then what we do with Frank is we drop a line going directly down, and we see how many people took longer to complete the cycle than Frank did. Well, Frank took roughly 52.5 minutes to complete the cycle, and now we can see that there's 1, 2, 3, 4, 5, 6 people who were slower than Frank. Brian did not enter the race, but suppose he had, and suppose that he completed the cycle in 52 minutes and the run in 18. Explain what this performance would be very unusual. So 52 for the cycle and 18 for the run. So he'd be around here, 52, and then he'd be up at 18. Brian would be located here. Now this would be unusual because it's a very quick running time in comparison to the cycling time. So just type that in. Okay, 1 second. This would be a very unusual result because Brian's cycling time is so slow in comparison to his running time. the scatter plot shows that usually a good cycle time will result in a good run time. Okay? Because usually in the graph, the lower your run time, the lower your cycle time. So if I was to redraw this line here, okay, dead center. Usually if you get like a 15-minute cycle, you should have a 30-minute cycle, you should have a 15-minute run. If you have a 40-minute cycle, you should have a 24-minute run. But to have like a 18-minute cycle, 18-minute run, sorry, this means that he should be on around a 33, 34-minute cycle, but he's actually down on 52, which is highly unusual. Okay, next one. Myra knows already that male athletes tend to be slightly faster than female athletes. She also knows, sorry, let's do this here. Okay. She also knows that athletes get slower as they get older. She thinks that male athletes in their 40s might be the same as female athletes in their 30s. She decides to draw a back-to-back stem and leaf diagram of the times of these two groups for the swim. There are 28 females in their 30s and 32 males in their 40s. Here's the diagram. Okay, so describe what differences, if any, there are between the two distributions above. Well, what we could do is we can get the mean and the mode. So we can get the mode and the median. So we say the mode on this one is which number comes up the most. Okay, so 16.2, 16.8 is quite common. You can see, so the females has 2 modes, or scratch that, has a 4 modes. So if it has more than 2 modes, it has no mode. Okay, so what I mean by mode is no most common result, because it has it has two 16.2s, it has 2 16.8s, it has 2 19.0s, and 2 21.3s. Okay, so that's not, it has no real mode. Okay, so then we can go on to the male section and see if it actually has a mode. So we see 7.7 is one, 7.7 is the other one, 9.9. So as it turns out, this one has no mode either. Okay, so it has no small mode, like as in, so it has no specific modes, as in 16.7 or 17.7 is the mode. But what we might want to try instead is a modal range. Okay, modal range means not a specific value, but a range of values. So you can say a modal range, or the most common range. Okay, a modal range of, so which one has the most? 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. So that's 7 people were in between 16 and 17 seconds. So it has a modal range of 16.0 to 16.9 minutes. Or 16 to 17 minutes, not including 17. Okay, and then in the male one we have 1, 2, 3, 4. So the male is bimodal, has two modal ranges, or bimodal, of 16 to 17 minutes, and this one here, which is 19 to 20 minutes. Okay, so that's one. Now another one could be the range. You could do the range of values. The range for the females. Now remember what I mean by range. Range is the top value minus the bottom value. So the range is going to be 29.7 minus 13.4. This one here and this one here. take them away from each other, and we get 16.3 minutes. Okay, so that's the female's range. And the male's range is going to be 23.0 and 14.9. So we got 23.0 minus 14.9, and what we get here is should be 8.1. And we get 8.1 there. Okay, 8.1 minutes. Okay. Now you could also look at it from a different point of view. And a different point of view could be the shape of the diagram, okay? So you could be looking at this here, and if you were to turn it on its side, okay, it looks something like this. Okay, and that's one of them, and the other one is like this. Now we can see that the male distribution is more symmetrical. What I mean by symmetrical is it's more like just even on both sides down the middle. Okay. While the female one is positively skewed, because you can see that it comes at the start and then there's a big tail off at the end. Okay, so this is the female distribution is more skewed. Okay, so that's another one you could have said. Okay. Now, Moira drew the diagram because she thought these two groups would be about the same. Do you think the diagrams would cause Moira to confirm her belief or change her reason? Well, as you can see that the majority of the grouping are all within the same time interval. So what we can say here is that if we were to take this part here, just the range of values from maybe 15 to 21. Okay, so look what happens here. Okay, we'll count how many males we have. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, so 30 out of 40 men, 30 out of 40 of the men ran a time between, so they ran a time between 15 to 22 seconds, okay, or 22 minutes. Okay, that's 75% of all men ran that time. Okay, and then on the female front, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay, so 23 out of 28 women. Now what's 23 out of 28? We need that in percentage form. 23 divided by 28 multiplied by 100. And what we get there is we're going to get 82% of all women. So 82% of all the females ran a time between 15 to 22 minutes. So basically, in a nutshell, I think Moira can keep her belief because most of the females, 82%, ran a time between 15 and 22 seconds, while 3/4 of the men ran between 15 and 22 seconds as well. If she wants to change her belief, she's going to need a bigger sample size, okay? Alright, next question. Question A. A stand is being used to prop up a portable solar panel. Okay? It consists of support that is hinged on the panel near the top and an adjustable strap joining the panel to the support near the bottom. By adjusting the length of the strap, the angle between the panel and the ground can be changed. The dimensions are as follows. We want to find out how long the strap has to be, in order to make an angle alpha between the panel and the ground equal to 60 degrees. Okay, so let's fill in some values here. Okay, so A to B, A all the way to B is 30. AD, which is here to here, is the same thing as CB, which is 5. Okay, well that in turn, because A to B is 30, it will make the panel length 20, because it's 20 plus 5 gives you the 30. CF is 22. That's from here all the way down to here. Okay, and EF is 4. So EF being 4 takes away 4 from the 22 to give us the 18. And the full thing here will be 22. How long has the strap? We want to find out how long the strap has to be to make the angle alpha, which is located here between the panel and the ground, equals 60 degrees. We want to find out how long the strap has to be in order to make the angle alpha between the span and strap. Okay, so the two diagrams are given below, CAF and the two diagrams are given below. One showing the triangle CAF and the other showing the triangle CDE. Use the measurements given above to record on the two diagrams below the lengths of these two sides in each triangle. Okay, so we're looking to find out what D is, so let's fill out our small triangle first. It's going to be 20 and 18. So it's going to be 20 and 18. The large triangle is going to be 25 and 22. 25 and 22. Okay, now there's a rule called the Sine Rule. Okay, and the Sine Rule is used to find out angles. Okay, so to use the Sine Rule, what we need to do is we have one angle and we know the side opposite that angle, and from this we can find out what angle X is. So the Sine Rule works as follows: you get sine A over its opposite side equals sine B over its opposite side. So it looks something like this if I had a triangle. Okay, so if I had a non-right angle triangle, something like this. Okay, basically if I have angle A, all I need to do is divide it by length A, and then if I have angle B and I have length B, then I can put them equal to each other using this ratio here. Okay, so what we're going to do is we're going to use this rule for the triangle above. Okay, so we're going to get sine X over 22. Sine X over 25, excuse me. Sine X over 25. X over 25 equals sine 60 over 22. Now what we're going to do next is we're going to get sine X on its own first. So we're going to get 25, cross multiply 25, we're going to get 25 sine 60 divided by 22. Put that into the calculator, we're going to get 25 sine 60 divided by 22. And what we get here is this number here, 0.984. Okay, and then we have to find out what X is. Now to separate X and sine X, we need to use sine inverse. So it's going to be sine inverse whatever this answer is. Okay, it's going to be 0.94. So sine inverse 984. Okay, so let's sine inverse that. Shift, see the sine inverse button, and I'm going to put in my answer, which is 0.984. This means that sine inverse is 79.78 or 79.8, we'll say. Okay, so the angle X is 79.8. So now we know that X is 79.8, which is located up here. We can now figure out what is this angle here by taking it away from 180. So we're going to get 180 Okay, so the first question was to get taking alpha equal to 60, as shown, use the diagram CAF to triangle CAF to find the angle CFA correct to 1 decimal place. And correct to 1 decimal place, we have it here, it's CFA is this corner here, and it's 79.8. Okay, so we have 79.8 there. Okay, hence find the angle ACF correct to 1 decimal place. So that's what we're just on there a second ago. We're now looking for ACF, which is this one here, and it equals 180 minus 60 minus 79.8. Okay, so 180 minus 60 minus 79.8, and what we get there is 40.2. So it equals 40.2. Now remember, this is in both triangles, 40.2, and this angle is a common angle, so it's 40.2 in both of them. Okay, so we can move on here, we get 40.2. Use the triangle CDE to find DE, the length of the strap correct to 1 decimal place. Okay, so we're looking to find out the length of this strap. So to find the length of this strap, what we're going to do is we're going to have to try the cosine rule. Okay, so we have a triangle here, and the triangle has 3 sides and 2 lengths, and you know the angle in between. So the cosine rule is a rule for something like this. Okay, so cosine rule is basically this: you have a triangle and you have an angle A, and this is in your notes. You have an angle A, and you have this length A, which is opposite the angle A. Okay, and then you have lengths B and C, and the formula is A squared, which is the length of A, equals B squared plus C squared, which is the two of them, minus 2BC cos A. Now in this question we know the angle is 40.2, so big A is going to be 40.2. Small a, we don't know what it is, so we might as well just keep it as small a. B is going to be 18, and C is going to equal 20. B and C, doesn't really matter which one's which, but A and capital A are very important. The length of the side A and the angle of A. So what we get now is this. We're going to get A squared equals B squared, which is 18 squared, plus 20 squared, minus 2 times B, which is 18, times C, which is 20, cos 40.2. Okay, so we're going to put all this into our calculator. 18 squared plus 20 squared minus 2 bracket 18 bracket 20, and then we're going to put in cos 40.2. Close bracket, and what we get is 174.0, so 174.1, let's say. Now we have to square root this to get the answer for A, so let's square root our answer, square root of answer, and we get 13.19 or 13.2. So 13.2 is the length of the strap. Okay, so that's all our workings for that one. 13.2 centimeters. Okay, this one here is also centimeters. Now, question 9. The diagram below is a scale drawn of a hopper tank used to store grain. An estimate is needed of the capacity / volume of the tank. The figure of the man standing beside the tank allows the scale of the drawing to be estimated. Give an estimate in meters of the height of the average adult male. Okay, so the height of the average man is around 6 foot. 6 foot, or thereabouts, is 6 multiplied by 12, which is 72 inches. Okay, and 72 inches multiplied by 2.5, because there's 2.5 centimeters in an inch, and what that will get us is 72 multiplied by 2.5, and that will get us 180. So 180 centimeters. or 1.8 meters, because you divide it by 100 to change centimeters into meters. Now let's count how many blocks. There's 6 blocks. 1, 2, 3, 4, 5, 6. So 6 blocks equals 1.8 meters. This means that 1 block is 0.3 meters. Use your answer part A, estimate the dimensions of the hopper tank, write your answers provided in the diagram. Okay, so the tank, alright. So what we're going to have to do is we're going to have to measure the tank and do it, count how many blocks there is and multiply it by 0.3. So let's begin, okay, so we can go here to here is going to be, let's count how many blocks that would be. Oh, it's here. 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 8 multiplied by 0.3, which is going to give us 2.4 meters. Okay. The next one is going to be roughly about 2 and 2/3, about 2.7 blocks. So 2.7 blocks multiplied by what's it, 0.3. So 2.7 multiplied by 0.3. Okay, is going to be 0.81. So this is 0.81 meters tall. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 8.7 blocks again, roughly. So this is going to be 8.7 blocks multiplied by 0.3. We'll see what it is this time. And what we're going to get there is 2.61 meters to go from here to here. And finally, I'm going to count that as 0.3 of a block. 1.3, 2.3, 3.3, 4.3, 5.3. 5.3 blocks multiplied by 0.3. 5.3 multiplied by 0.3. And what we get here is 1.59 meters. Okay. So where we're at next is we got to estimate the using the tank to be a cylinder with a cone above and below. Find the estimate for the capacity of the tank in cubic meters. Okay. So what we have here is a cone above, a cone below. So if you will, we have a cone above. So we have a cone above, a cone below. So the cone below will be face down. Okay, so cone above and cone below. So that's the cone above and the cone below. There'll be different sizes. Same radius but different sizes. And then in between we have a cylinder. Okay, so the cylinder is in between. So we'll just draw our cylinder in between. So this is what it should look like when we break it up. Now what we gotta do next is we gotta figure out what is the volume of each individual part. Okay, so we look up your notes and you get the volume of a cone is 1/3 pi r squared h. Volume of a cylinder is pi r squared h, and the volume of a cone is still 1/3 pi r squared h. Belongs to each one. Now each one has different dimensions. So the height of the bottom cone is 1.59. So this has a height of 1.59. The height of the cylinder is going to be 2.61, and the height of the top cone is 0.81. Now, in all cases, the diameter is 2.4. So the diameter of each one is 2.4. and that makes the radius 1.2. So each one has a radius of 1.2. And now it's just a matter of entering them into the formula. A third pi 1.2 squared times 0.81 plus pi times 2.61 squared, the radius squared is 1.2 squared, times 2.61, and then plus a third pi 1.2 squared times h, which is 1.59, close bracket. Now we've got to do all these, best to do them individually. So we start off with a third pi r squared is 1.2 squared times 0.81. What we get here is 1.22. So 1.22 plus, now we're going to do this one next because there's very little difference between this one and the last one. It's going to be 1.59. What we get here is 2.397, or just 2.4 for the last part. And then finally the part in between, where we have to get rid of the third. Okay, bring back our pi and our bracket, and then we have to get the height, which is going to be 2.61. And what we get here is 11.81. Now we need to add all three together to find out what is the total volume of this full object. 11.81 plus 2.4, and what we get here is 15.43. So 15.43 meters. So the answer there is 15.43 meters cubed, and that's the end of this paper.